Hello everyone, this is the topic regarding substation instrumentation, which is advances which is used in renewable as well as renewable, conventional as well as non-conventional energy sources. Sharad Institute of Technology, College of Engineering, Edra Vichalganji, presented from Department of Electrical Engineering, presented by Ms. S.A. Banne. So firstly, we will see the all over information regarding MSETCL, that is the Maharashtra State Electricity Terminated Corporate Limited. So all over MSETCL so functions as whenever we considering all over high voltage and extra high voltage substations, according to that the number of substations available, that is called transmission license. Second one is state board dispatch center, we can also say SLDC in short form. Next one is state transmission utility, that is STU. So MSETCL presents infrastructure as on the whenever the research of 31st March of 2018. So this is all over information or table whenever the researching and getting the all over information area. Okay, then first column is voltage level, second one is EHV, extra high voltage substation. Next one is transformation capacity, that is in mentioned in MVA. Then now last one is EHV line, extra high voltage lines, that is circuit kilometer. Okay, then voltage level capacity, according to voltage level capacity, then EHV substation is installed then all over Maharashtra. So first one is 765 kV. The substation is one in Maharashtra. Then transportation capacity of in MVA, that is 3000 and EHV lines is 0. The next one is 500 kV HVDC. The EHV substation is available 2. Then transportation capacity is 3582 and EHV line is 1504. Next one is 400 kV voltage level. According to that, the EHV substation is 31 in Maharashtra. Then transformation capacity is 30,045. Then EHV lines is 8,415 point something approximately. Then according to this all over information, 400 kV, 220 kV, 130 kV, 110 kV, 100 kV, and finally 66 kV. So according that all over voltage capacity, the EHV substation is going to be installed. So this is all over information or getting the reports whenever the researching at 2018. This is the picture of substation whenever the voltage extra high voltage level capacity is installed there. This in that particular switchyard system, the number of incoming and outgoing lines are available, which is connected in feeders. In that particular feeders, the incoming lines and outgoing lines are going and connected to the number of villages and number of cities where is the domestic appliances, where is domestic applications as well as industrial as well as agriculture level applications is available there. So this is number of transformers is available there according to rating that voltage ratings. Next one is the most important all over device, that is called online DGA. DGA means that is digital ground analysis. So this is all over measurement system whenever it is provided at oil flange of the transformer. This all over instrument is used for particular transformer. So oil flange of transformer it is provided, then it continuously monitoring the following parameters, and this parameters is relative humidity of transformer. Next one is temperature, because of whenever the temperature is going to be out of level or all over rated level, then it is going to be create, it is the possibility to create the abnormal conditions. That's why it is very needed to monitor time to time of temperature of transformer. And last one is ppm water. So this is all our important points, important parameters which is continuously monitoring needed. And last one is total gas contents. in that particular transformer the total gas is available, so all our contents of gases is going to be monitored needed, so that's why this DGA is going to be used there. Then next slide is partial discharge measurement. In that particular advanced techniques, the partial discharge measurement is also important for the transformer capacity. So transformer capacity and baseline, all our graph is shown in above figure, and the space between the baseline and measurement indicates the strength of the PD, that is partial discharge measurement. In that particular graph, the lines of blue and the lines of red, blue lines is indicated for transformer and red line is indicated for baseline. So difference between that red line and blue line, it is the distance or space between the baseline and measurement indicates it is the strength of PD. So it is most important part to measurement of partial discharge. So whenever we considering about the transformer, regarding transformer means what, that is the static device, means there is no rotating parts is available there, and it transfers the energy from one circuit to another circuit without changing frequency. So it is needed to stay a frequency is constant, that is 50 hertz. So for that purpose this is also available. Then next one is residual life assessment, that is also we can say RLA. What is this RLA, residual life assessment? It is the study the trend of DGA results. Next one is study the trend of the TAN data results. Next, the study the degradation of cellulose, that is also we can say furan test. So this is all our study involving in residual life assessment. Then next slide is regarding tan delta measurement. Tan delta measurement according to IC and IR. There is a resistance and capacitance. This is the best parameter which is including in circuit parameters. So capacitor have the current, that is indication of IC, and resistors have current is indication of IR. Whenever we taking the tan angle according to voltage and current, then the tan delta is going to be indications. This is the opposite side divided by the adjacent side. So this is all our angle calculations regarding tan delta measurement. So tan delta measurement have a different level devices, that is which is shown in all over slide. So this is the device for the tan delta measurement. So tan delta measurement have a different level all over tables, the according to bushing system. So 400 kV, 220 kV, 33 kV, one more 33 kV, LV or HV windings, sample R phase CGL make ICT second. So this is all our number of bushings according to the bushing. The PF is allotted, and then tan delta measurement is going to be calculated. So for 400 kV, for 220 kV, for 33 kV, and for all our HVLV windings. So for that purpose, according to that device, the tan delta measurement is going to be done there. Next one is most important part, that is the SFRA, that is called sweep frequency response analysis. So sweep frequency response analysis is important also for transformer are made up of complex RLC networks. So in that particular all our electrical engineering circuit, the three parameters is important, that is resistance, inductance and capacitance. Without this all our parameters, none of the circuit is going to be completed. So resistance, inductance and capacitance are connected in three-phase system according to their space. So whenever we see the circuit diagram which is shown in above figure, the transformer are made up of complex RLC network. Any physical damage results in changes to these RLC networks. These changes in the RLC circuit is what we are looking for. So according to all our resistance, inductance and capacitance connected, whenever we see the connection between of resistance and inductance, it is connected in series, and also according to that resistance and inductance, the capacitance is going to be connected in parallel. So for that system, for that system, this all over circuit is going to be important there. Next one is analysis of sweep frequency responses. So sweep frequency responses that is needed of SFRA. So this SFRA is none of the important points. What is the sweep frequency responses? That is the that is all over SFRA test is nothing but a sweep frequency responses analysis which is used to find out the physical condition of transformer windings, alternator, rotors, windings, etc. So sweep frequency analysis, it is the analysis. Double engineering sweep frequency responses analysis is one of the most powerful diagnostic tools for assessing mechanical damage to a transformer winding. Analysis of the results, which are in the form of frequency response traces, can, however, be during to new users. So it is very beneficial. Whenever at the low frequencies, which is inductive circuit and magnetic circuit, significant differences in the responses between the outer two phases and the center phase, which is shown in all over figure. Whenever we taking the all over graph, the inductive responses and capacitive responses is going to be done there, and the resonance between these all over occurs according to their frequency. Typical responses. Typical response of a healthy transformer starting a decibel value is what we would expect. The shape is consistent with a star configuration. All phase line up with each other. So this is all our typical responses. One more, this typical responses of transformers. Typical response of a transformer with huge problems. Starting decibel value of the white phases is unexpected, which is shown in figure. White phases is unexpected. The shape is not consistent with a star configuration. Phase do not line up with each other. Clear frequency shift with the information of new resonant point. Next, images of SFRA kit. SFRA means, that is, which is already seen, sweep frequency response analysis. This is analysis it done is one of the most powerful diagnostic tools for assessing mechanical damage to a transformer winding. Analysis of the results, which are in the form of frequency response traces, can, however, be doubting to new users. So this is all over regarding SFRA kit. Next one is CTR nitrogen cooling system. So what is the purpose of this cooling system? On receipt of required activating signals, a predetermined quantity of oil drain commences. Simultaneously, nitrogen is injected under pressure at a predetermined flow rate to create a stirring action, thereby bringing the temperature of the top oil surface below ignition point. Fire is extinguished within 30 seconds maximum. Nitrogen gas occupies the space created by oil drain and acts as an insulating layer between the oil in transformer tank and fire above the top cover. This is all over transformer system overview, which is exactly connected. Firstly, we see the big area of transformer tank. Upper that, all over transformer tank, the three bushings are connected, and in between that fire detector is also connected. Next, it is according to conservator way, the backhouse relay is also connected. Then transformer conservator isolation valve is also connected. Then pressure relief valve, then oil drain, pressure regulator, N2 releases device, nitrogen injections, control box, operating signals from control room or relay panels, nitrogen venting wall, fire extinguishing cubicle, quick oil drain valve assembly, and finally is oil pit. So this is all our important parts which is assembly in all our transformer foundation or transformer work. So this is all our important parts. In particular, backhouse relay is also used for whenever the abnormal conditions is created. At that time the backhouse relay is going to be operated, and finally it is going to be extinguished, or it is going to be finished any type of fault. So for that purpose backhouse relay is also important. Next one is mechanism and control box. So for the substation working indoor or outdoor system, as well as in switchyard system, the mechanism system is important, and control box is going to be connected in every substations. So this is the all our mechanism and control box. Next picture we will see the all over abnormal conditions results in all our switchyard system or where the transformer is going to be installed. So suppose in case abnormal condition is going to be, or temperature of the transformer is going to be increased, or it is going to be above level from the rating level. So at that time the temperature is going to be increased and heat is going to be generated. So at that conditions the all over fire is, it is a possibility to generate a fire. But in switchyard system or in substation system, for fire extinguishers system is also available. So emergency system, if abnormal conditions is created, then for the precaution purpose the number of fire extinguishers or any other methods which is easily available for the emergency system to extinguish this all over fire. Because of this fire it is very harmful to any human beings, it is very harmful to any number of proper and uh, costly devices. So this is the picture of proper device or proper installations or proper foundation for installation of all our transformers, and three bushings are connected to number of feeders, that is have the incoming and outgoing lines. Next one is important point in switchyard, that is called circuit breaker. Circuit breaker means what? Circuit breaker, it is a device which make or break the circuit whenever the abnormal condition is going to be created. Suppose in case abnormal condition is going to be created, at that time the relay is going to be sense this fault and send the signal to the circuit breaker. So after that getting the uh, number of signals from relay, then circuit breaker have take a decision to make or break the circuit. So for that purpose in every line or every phase circuit breaker is going to be used there. Next one is contact resistance measurement, that is also called in CRM in short. This is measure the resistance of breaker contacts when it is going to be closed system. Next one is, that is the CRM of isolators. So in different locations the CRM isolators is going to be used there. In particular isolators in connected in RYB in up to 3 phase according to their all over locations. In for example Jezuri 29A, Jezuri to 29B, BC 29B, TBC 29B. So this is all our capacity in case Jezuri, in case Baramati. Then in case of this all our system, the resist RYB phases is going to be fluctuated. Then next one is dynamic CRM. In that particular dynamic CRM is used to measure the resistance of breaker contacts during movement. That is the movement of dynamic movement. So condition of this contact is ascertained without opening interruption chamber. So dynamic CRM is going to be used there. This is the picture of healthy contacts of circuit breaker. Healthy contacts means According to that context, there is none of the possibilities created for abnormal conditions. So for that purpose, it is called healthy context of circuit breakers. Then eroded finger contacts. So old type eroded finger contacts have two types. In old type system that is shown in figure, and new type system for the precautions or all over protection purpose, that is the new system is available now. Next one is typical DCRM signature. In that particular breaking contact signature, that is the all over graph system is according to RYB in three phases. At that time, the all over typical DCRM signature on RYB as shown, that is the indication of resistance travel and all over current system. P1 means, that is P1 point is indication of arcing contacts of touches. P2 is indication of main contact touches. P3 is indication of main contact separates, and P4 is indication of arcing contact separates. So this is all over typical graph. Thank you. If you have any doubts, you can mention in comment box. Thank you.